Alright, Crewton Ramone's House of Math. Here is a quick lesson on ratios. And look, I've set it up where it is concrete drawing symbols. So we're going to start here. And once again, I want you to understand that this is not the right way to do it. So I'm going to show you, this is training for you very quickly. Right here, yeah, that's a 2 and a 4, but that's not going to help you. But well, it is, but it'll make it easier if you mirror the blocks a little more closely. Because what a lot of you try to do is make the blocks match the symbols. No, the symbols match the blocks. So take this away, turn this like this, and now we're happy. Now I can see that 1 times 4 is the same thing as 2 times 2. Somebody figured that out a long time ago. So if I put 1 is to 2 is the same thing as, I don't know, is to 4, well, all I have to do is figure out what this is. Well, that's 4. So, of course, 2x is the same thing as 4. So x must be 0, 0. Nope, no fun, get back to 1. X must be the same thing as 4 divided by 2, which is 2. Okay, let's try another one. How about, we get a little bit bigger, 2 is to 3 as 6 is to 9. I can put my lines in there if you want to, just for fun. You can put a bar there, put an equal sign. And again, do we want to use these blocks? We don't want to use the blocks. Well, let's quickly draw a picture of it. So I'm going to have 2 is to 3. Notice my 3 is this way, not this way. And let's see here. Get rid of these guys, because we're going to do it right. So here we have 2 is to 3 as 6 is to 9. Let's figure this out. Well, let's see here. So I'm going to need 6 here. Get rid of this. And let's see if I take this and this. Can you see that this times this is going to be the same thing as this times that? Well, let's see here. What I'm seeing here is that 2 times 9, that's 2 times 9, and see, it's not visually obvious here, is the same thing as 18. And over here, well, 3 times 6 is in fact the same thing as 18. And again, let's say I wanted to do it down here this time. So 2 is to something as 6 is to 9. Well, let's see here. If I do my cross multiplication, you'll see, I realize that a lot of you guys just memorize the rules, you don't know why or how it works, but I'm going to show you, using these blocks, a slightly easier way to make this work. But anyway, 2 times 9, x times 2, so I'll have 6x is the same thing as 18. Well, let's see here, 6 is the same thing as, 6x is the same thing as 18, no fun, get back to 1, no fun, get back to 1, x obviously has to be 3. Because, why? Well, because 3 times 6 is the same thing as 2 times 9. Alright, let's try a slightly different approach. Because when the numbers get bigger, you're going to see that, yes, this works every time, but it's the math starts to get very tedious because the numbers start to get big, and anyway, we're going to fool around here and make it easier. So let's look at this a slightly different way. Can we see that all I have to do is, and I can fool around and reduce these later, but we can see, or fool around with ones that we have to reduce, that, let's see here, this is 1 by 2, this is can you see that over here I just moved over by 3? In fact, if I have my base 10 blocks, or my multi-10 blocks, I can see that I have a relationship here of 2 to 3. Anywhere along here, it's 2 to 3. So if it's 2 to 3, then it's just a matter of, well, how far did I move? Well, I moved 3 this way. So if I move, this is 1 and this is 2 and this is 3 and this is 1. Well, let's see here. If I move over here by 3 and that's 2, well, that has to be 6 right there. If I move over here by 3 and that's 3, this has to be 9 right there. So again, let's say I don't know what this is. Well, if I don't know what this is, but I know that I've moved over by 3 because this number right here is 3 times that number, well, this number right here has to be 3 times this number. What's 3 times this number? 6. So basically, it becomes a matter of doing some division. You see what I did there to figure it out? Now, when it works out to be a much larger number, I'm not going to use blocks for the larger example, but always start in the concrete when you start your lessons. But let's say I have a much bigger problem where I know something like, oh, I don't know, let's say 3, oh, let's not even make that, let's go 6 to, make it simple. 6 to 10 is the same thing as, oh, we want to make it hard? First off, we're going to want to reduce this. Can you see that this is the same thing as 3/5? Well, just leave that as an aside. So over here I'm going to put this to be 15, and over here I don't know what this is. Alright, if we do our 6 times x is the same thing as 10 times 150, wow, that gets to be the math, like I said. Even when it's a 10, it still gets to be kind of big. But let's see here. How far over is this one? Well, actually, I'll do it this way. Like I said, if I can reduce this, I can figure out that my 6 is to 10 is the same thing as 3 is to 5. Well, let's see here. 3 to 5, 6 to 10. How far over did I move this one? And I can actually even draw the boxes so you can see. Well, this is 1 and 1. This I moved over by 2 and 2. Do you see? They're actually, that this is 5 times 2 is 10. Okay, now, well, how far do I have to move over to get to 15? Well, 5. So this is 5. And since this is 5, well, we know it's 5. This is 5. This is 5. What's 5 times 5? 25. I think 5 times 5 is 25 is a lot easier than trying to do 6x equals 150. Even though this is a fairly simple number. But let's see here. No fun, get back to 1. No fun, get back to 1. I know that 150 divided by 6 is 25. But what if I'm a little kid and I have to do this math and this division? And can you see the division right there, actually? That really what we have is 150 divided by 6, or 150 over 6. And what you're going to see here, let's go this way, is that we just turned it sideways. 6 is contained in 150 25 times. That's easy. Alright, one more and we quit. How about something crazy like 9/24. That looks fun. And can you see the 1 there? What's the 1 there? If I took a 1 out of each one of those. And then over here, see that, I'll make it like ridiculous, where it's, I'll make it bigger than 9 even. How about, 21. Ooh, that'll be lovely. And we'll make this 56. Actually, we don't know what it is. I want to know what that is. Alright, well, let's see here. If I do it the easy way, then all I have to do is reduce this, and I hope you can see that the 1 here is 3. I just moved over by 3, and this is 3/8, because that's 1. Actually, I'm putting equal sign there. And now over here, well, what do I have to multiply 3 by to get to 21? 7. So I must have multiplied by 7 over here. And since I know this is 8, this has to be 56. Now, I'll leave the other math for you. Because that's a 3, that's a 3, that's an 8. I'm just drawing the sides of the rectangle. Of course, that's a 3 and an 8. That's the reduction. So x here. Let's see here. So what you would have to do is, if you just follow blind rules that you don't know why or how, what is 21 by 24? Right? Even just doing that math, and then we have to divide that by 9. So let's see here. Let's do some simple 2-digit multiplication here. 21. So what do I have? I'm going to have 4 hundreds. 2 tens and 8 tens is 10 tens. And 1 times 4 is 4. So 504, that's fun. And now I have to take 504 and divide it by 9. You're going to get 56, but do you want to? In fact, I can grab a calculator here and show it to you if you want, but do your own math. But 20, I mean, is that easier? Or is it just 8 times 7? Because 8 times 7 seems a lot easier to me. But let's bust out a calculator just for fun. Okay, so we'll clear that. And 21 times 24, 504. And then divide that by 9, and sure enough you get 56. But I mean, that's a lot harder math than just multiplying 7 times 8, or 8 times 7. Do you see? But now you understand why this times that is the same as this times that. And I showed you an easier way to do it. Alright, Crewton Ramone's houseofmath.com for more.